everyone, Jason from Makera here with another project tutorial, and in this one we're going to create a backyard table game using Makera CAM and the Carvera Desktop CNC. Both the Carvera and Carvera Air are highly versatile desktop CNC machines, allowing you to work with a range of materials, bits, and manufacturing processes to create fun projects like this one. And Makera CAM allows you to import a range of file types to easily prepare your designs for manufacturing too. Now in this tutorial, we're going to look at how to create this game from start to finish, so let's get started. You can download the example files used in this tutorial from the knowledge sharing page on our wiki site, or download the completed Makera CAM files instead if you want to get right into machining. There are 3 files needed for this project, one for the top and bottom of the board each, and one for the ball launchers as well, and then an optional file for the engraving design too. Once you have your designs, head over to Makera CAM to begin to prepare them for manufacturing.
So after launching Makera CAM, we can create a new 3-axis project. And the first thing we always want to do whenever we make a new project is to set our stock to match the material that we'll be using. So I'll be using a piece of 3/4 inch plywood, and plywood usually machines best as a hardwood. And the length of my plywood is about 330 millimeters by 240 millimeters by 19 millimeters. And again, it's 3/4 inch plywood, so that's just over 19 mil, but this should be perfectly fine as we're going to machine through. Whenever you're going to flip something horizontally, like we'll be doing in this 2-sided project, it's really important that your horizontal length is very accurate, right? So that way your part is oriented correctly during the flip. So this is the most important measurement. So make sure you have that down correctly there. And once you've adjusted your stock, you can click OK. Now, this is going to be a 2-sided project, which means we're going to have 2 work coordinate systems. So I'm just going to real quick edit the work coordinate system 1 that we have here, and I'm going to rename this to be bottom, because we're going to machine the bottom first. And then I can import the DXF file for the bottom. So I have my Table Toss Game bottom profile that we've downloaded from the wiki. So I'm going to open this up and import this in, and you can see we have our bottom profile. So then what we can do is we can select this whole graphic and we can transform it. So I'm going to first rotate it 90 degrees, and then I'm going to align it. And if I click Quick Align Stock, that'll just center it perfectly in my stock here. Okay. Now, before we get too far in preparing the toolpath, so let's go ahead and import all of our graphics and align them for the top as we go here. So I'm going to click New Coordinate System, and I'm going to rotate this just like I would actually flip my stock. So I'm going to horizontally rotate it here, and we have to select the origin point for what will be the new bottom left corner when we flip our stock, which would be this corner right here. And I can rename this coordinate system to be top. And whenever you make a new coordinate system, you'll see you have a whole new collection of layers and graphics here. So we have different graphics and paths for the bottom and top profile. We can still see the shadow of our bottom profile here. So let's go ahead and import the graphics for the top of our design. So that's going to be the top profile. And before I move anything, I'm also going to import the engraving profile, which is optional if you want to engrave this stripe here. I'm then going to select both the top profile and the engraving profile. And again, we can use the transform tool to rotate this. And I can either use Quick Align Stock or manually position this, but I really want to center it perfectly on my bottom graphic. So the easiest way to do that is using center to center. So if I click center to center, I'm going to select my reference graphic, which is going to be the outline of this top profile. You can see it's highlighted a little bit more bold now. And I'm going to select my target graphic, which is the outline of my bottom profile. And that will automatically center my designs. And of course, because this is a symmetrical design, top and bottom, we can see that those lines overlap, right? So I'm going to close this. Now we have our graphics fully imported for this design, and we have our flip set up, and we can start to prepare our toolpaths. So let's head back over to the bottom work coordinate system. And what we'll do is we're first going to make some alignment holes that we'll use to flip our stock around when we do our horizontal flip. So we're going to use the create tools here to do this. So I'm going to create a new 2D model, And we're going to make a circle that has a diameter of 1/8 of an inch, or 3.175 mil, or whatever size pins and drill bit you want to use. So I have 1/8 inch alignment pins that I'm going to use. So I'm going to drill an 1/8 inch hole. And I'm just going to go ahead and draw a circle somewhere here on my stock on the left-hand side. It doesn't actually matter where it is in relation to your part, because again, our parts are already aligned. So as long as we flip our stock horizontally and these pins are perfectly centered on the stock, then that's perfectly fine. So if you're a little high or a little low in terms of the center point of your design here, that's not actually going to make a difference. So it's not really crucial where this is. However, if you did want to set a really accurate position for this, you could head over to the transform tools and go to the move tools. You could manually set, X and Y positions and align this perfectly. But what we're going to do is we're actually going to mirror this over our stock center. So I'm going to click mirror down here, and I want to create a copy of this hole, and I'm going to mirror it horizontally over the stock center, not the center of the shape. So if I click generate mirror, you'll see that that gave me a hole on the other side, perfectly centered on my stock. So this is where I mentioned that 330 mil length of your stock is really important. So that way when you flip this guy horizontally, everything is nice and aligned for your top and bottom. So we have these holes. I'm going to close that. And with the holes still selected, this will be our first toolpath. We're going to create a 2D drilling operation to drill through our board and also into a piece of wasteboard below, so that way we can insert our alignment pins for the flip. So the end depth needs to be much past the stock, right? We need to drill through the stock and also deep enough into a piece of wasteboard for our alignment pins. So that's going to be, for me, about 25 millimeters. So that should be a nice hole depth of about 5 or 6 mil after I drill through my 19 mil or so stock, right? And then we don't need to change our clearance heights or anything like that, probably, unless you're using any types of fancy fixtures, but we do need to select a tool. And you would typically grab a drill bit for this, but I don't actually have a drill bit long enough to do this hole. So I'm going to use a single flute end mill, and I'm going to select my 32 millimeter single flute end mill, and I'll just do a drilling operation with this single flute flat end mill. And as long as I have retract enabled, that should be perfectly fine. So I've selected this end mill. You'll see that hardwood is selected for my, my machining feeds and speeds based on our stock that we set earlier. And I'm not going to change any of the defaults. The only thing I'm going to do is change my tool number, because I'm going to have this 32 millimeter end mill assigned to slot 2 in my Carvera's automatic tool changer. So you can assign the tool number as needed. And then again, this is where I said we want to have a PEC drilling function. So let's enable a fixed Z height retract, and 1 millimeter is fine. So that means that each step down, each millimeter step down, this drill bit or end mill will back out to a fixed height of 1 millimeter. So that way it's not just plunging straight through. That should stop us from breaking our bit and also overheating or burning anything and causing any damage there. So we'll drill a little bit more slowly. So we can calculate that. And when you have a lot of tool paths, it's always a good idea to keep yourself nice and organized. So I'm actually going to rename this path to be 2D drilling alignment pins, right? Like so. And that'll just keep my layers here nice and organized. So let's close this. And the next thing we'll do is we have a bunch of pockets to clear out, right? So I have these little magnet holes that will hold us shut when the board is shut there. So I'm going to select my 3 magnet holes, and let's create our first 2D pocket operation. I'm going to name this to be 2D pocket magnets. My end depth can just be 2 mil for my magnets here. So we'll go 2.5 mil for the magnets that I'm using. So end depth of 2.5. For the tool for this guy, you can use a lot of different tools. I'm going to use my 25 millimeter end mill, which is honestly quite a bit longer than what I need, of course, to do just a 2.5 hole. But I'm going to use as few tools as possible when I do this. So ideally, you'd use a shorter bit, maybe a 12 millimeter end mill or something like that. But I want to use as few tools as possible, do as few tool changes as possible. So a 3.175 by 25 millimeter end mill set to hardwood should work fine. So I'm going to choose that. Again, default feeds and speeds are great. You can check your tool number, but I do have this loaded. This is one of our example tools, so this is loaded in tool slot 1. Path strategy, we can do offset, which will work fine for working around these concentric holes. We don't have to change any other settings. We don't need ramping because it's not a very hard material. So I can just go ahead and calculate these pockets. There we go. All right. Next toolpath that we'll do is our hinge pins. And this is going to be another 2D pocket. So I'm going to hold shift and select the 2 hinge pins. And we'll make another 2D pocket. I'll rename this to be hinges. And the reason that we're doing this as a separate toolpath is we have a very different end depth. So I'm going to set the end depth for this guy to be 12 millimeters. 12 millimeters. Everything else is going to be the same. So same tool, same feeds and speeds, same tool number, offset strategy, still fine, no ramping needed. So I can just very quickly click calculate because Makera CAM will keep the same settings as your previous toolpath, which is kind of convenient. So there we go. That's nice and good. And you know what? Actually, this center pocket is also going to be a depth of 12 millimeters. However, I'm going to use a different strategy for this center pocket to clear it out a little bit quicker. So I can close this and create one more 2D pocket toolpath. This time we're going to select this center pocket, and I'm going to call this center pocket. Same depth, same bits, same feeds and speeds, but for this one, we're going to set a parallel strategy, which instead of working around in a concentric pattern like this, it's going to pan back and forth. And that's usually better for clearing out a large amount of material. So we'll set this to be a parallel strategy. Again, no ramping is needed, so we can calculate that. If I just zoom out for a second and orbit around, you'll see that we have all of our toolpaths here drawn so far. So we have our nice little toolpath lines there. And looking at that, it looks like I missed a hole for my alignment pin. So let me go back into my alignment pins and make sure that both of my holes have been selected. Looks like I accidentally missed one of them. Let me recalculate. There we go. All right. So we have one more toolpath to do for the bottom, and that is just going to be a chamfered lip. We're not going to cut all the way through our part, so we're going to save that for the top side, but we are going to do a chamfered edge, so that way when it does cut all the way through, you'll have a nice chamfered finish here, sort of like a routed edge, if you will. So let's select our outline, and we can create a 2D chamfering toolpath. All right, our chamfer depth for this could be 0.5 mil, so 0.5. You could, of course, adjust that if you wanted to chamfer a little bit more or less. And then the tip offset is going to be 0.2 for the size chamfering bit that I'm going to use. Then we're going to go ahead and choose our tool. And from the examples tools, I'm going to grab our 0.1 mil 90-degree chamfering bit. Hardwood selected to be our feeds and speeds. If you wanted to change these, you could, but I think the defaults should be just fine. You could, of course, change your tool number, but this is loaded in tool 6 for me, so that's perfect. We want to run along the outside of our part, and climb milling is perfectly fine. So I can calculate this, and you'll see that we have a very small chamfering line that runs along the outside of our part. So I'm going to close that. I didn't name this one because it's kind of obvious, 2D chamfer. We only have one chamfering toolpath. And if I hide my designs so we can just see the toolpaths, you'll see that we have everything prepared for the top. It's a good time to press save if you haven't yet, so we can save this project. And then we can head on over to prepare the top, right? I'm sorry, this is everything that we have prepared for the bottom. Now we can flip and head over to our top graphics. And if you find that it's a little distracting to see the toolpaths on the bottom, you could always hide your toolpaths. So that way when you flip and you're looking at the top, all you see is your top design. So the first thing you might want to do is this engraving profile, depending on how you're going to make the engraving profile. I'm going to use the laser to actually engrave this, the built-in laser of the Carvera or the optional laser for the Carvera Air. So I'm going to save this for the end. But if you were going to mill it, if you were going to do, let's say, a 2D pocket using a V-bit or a ball nose bit to actually clear this out and engrave this using a milling function, you'd probably want to do that first because you typically start with your smallest operations and then move to your biggest ones. But again, I'm going to save this one for the end because I'm going to use the laser. So my first operation is actually going to be all of these holes. for the cups here. So if I just select my holes and deselect my engraving profile, we can go ahead and create a 2D pocket. And these are going to be for the cups. So I'll name this to be cups. And then our end depth for this could be pretty shallow. So I'm going to do 3 mil for our end depth. And then for our tool, I'm going to select the same 25 millimeter end mill that I was using earlier. Same feeds and speeds, same tool number. We can do an offset strategy for this, and no ramping is needed. So I can just real quick calculate that. And actually, what we want to check real quick is to make sure that we're not going to accidentally interfere with our bottom pocket. So let me head back over to the bottom, enable our toolpaths, and then when I look at this from the top, we want to make sure that I don't accidentally plunge. If I look at this just from a side profile, I'm not going to accidentally plunge in. So you can see we have plenty of buffer here. That looks perfectly fine in terms of our 3 millimeter holes there. So that's good. All right. Next, we're going to do the pockets for the launchers. So I'm going to grab these 3 square pockets and make a 2D pocket toolpath. We'll call this launchers. These guys are going to be milled quite a bit deeper. So I'm going to mill this down to 12 millimeters. So that way the launchers can sort of slot in for our table game. Same bit though, same feeds and speeds, same strategy. So I can go ahead and click calculate. Again, the only reason we had to make this a separate toolpath is because we have 2 different end depths, right? 2 different end depths. And then we have our outer line here. So the first thing we're going to do is we're actually going to cut all the way through. So let's go ahead and select this outer line and let's make a 2D contour toolpath. Okay, this is the first contour toolpath we've made, right? This is going to be our outer profile. Our end depth is going to have to go through our stock. So for me, I'll make that 20.5 mil, just like about 1.5 mil. Again, I'm using 3/4 inch, so it's not quite 19 millimeters. It's a little bit thicker than that. So I want to make sure I go all the way through my plywood. So I'm going to go to a depth of 20.5 mils, like so. I'm going to need a nice long tool to do this. In theory, the 25 millimeter end mill is long enough, but when that's cutting really deep, there's not going to be a lot of bit left, and that could be getting a little hot. It's also not going to allow for really good chip evacuation if I'm putting this bit pretty much to its full depth. So I already have the 32 millimeter bit ready to go. So I'm going to select my 3.175 by 32 millimeter bit, set to hardwood. I'm not going to change my feeds and speeds, but I do want to change my number so I don't have to reload my tool changer. So that's tool 2. We want to run along the outside of our profile here, and we do want tabs to hold on to this part as it's machining. So I'm going to create some custom tabs, and whenever I'm working with wood, I like to use square tabs, and I'm going to make these tabs quite a bit bigger to make sure I hold on here. So I'm going to make them 20 wide by 5 millimeters tall, because it's pretty easy to cut some wood tabs. And I'm just going to click add and maybe add 4 tabs along the perimeter of my design. I want to avoid the front just because of the hinge pockets that we're going to cut like here. So there we go. So then let me calculate this. And if I just orbit, you can see we have our part that cuts all the way through our stock, as well as our tabs, which looks great. So we can close this toolpath. And then we're going to do a chamfering path, just like we did on the bottom. So we'll do a chamfering path now that this edge has been cut. We're going to keep the same settings that we did earlier. So a depth of 0.5 millimeters, an offset of 0.2 millimeters. We can select our chamfering bit, like so. And we're going to run along the outside. Calculate that. Oops, sorry. Let me click on my outline and then calculate that. And now we have our chamfering toolpath. So there we go. So that is the top prepared, like so. We already have the bottom prepared. And then all that's left is this engraving profile, which again, if you were going to mill it, you could have done it much earlier. But because I'm going to use the laser, what I'm going to have to do is vacuum my part really thoroughly before I actually start to laser engrave this to make sure there's no dust that could possibly ignite during the laser engraving process. So I'm going to save this guy for the end. So now with this engraving profile selected, let me make a laser vector toolpath. and I'm going to call this laser engraving profile. And we have to choose the right feeds and speeds for our materials, which you can grab on our wiki site for some good starting points. I know that hardwood, typically around 500 for the speed and 40 for the power, should work well. And the mode here is going to be fill, because I want to engrave this entire stripe. I'm not going to change any of my intervals or my angles or things like that, so this should all be fine. And when I calculate this, we'll have a nice laser profile. So there we go. So now we have all of our toolpaths generated. It's a good time to press save. And all that we have to do is export these guys for machining. So let me flip back to the bottom. I'm going to right click and save all of these paths at the same time. If you wanted to change any of your tool numbers or double check your tools that you need, now's a good time to do it. But let me export this for the bottom. And let me flip back to my top and I'm going to export these. But again, I don't want to export the laser as the single toolpath. I want to do that one separately so I can pause the machine and prepare it for laser engraving before I do. So I'm going to deselect the laser profile, export this guy for the top only, and now I'm going to right click just the laser profile and export this guy on its own. And I'll save this guy as something different. And we have all of our toolpaths exported for this. And before we start to manufacture it, we have to prepare our launchers. So after you press save, let's create a new Makera CAM project here, 3-axis project. I'll be using the same size stock, so I'm not going to adjust this, although there won't be any flipping, and also you could use a much smaller size piece of material, so you could adjust your stock size, but I'm going to be keeping it the same. So with that set, I'm just going to import the launcher profile. And the first thing we can do is just reposition this on our stock here. So I'm just going to drag this down to be a little bit closer to my origin point, right? Leaving some room for some clamps and things like that. And as you can see, you need a much smaller piece of stock. So you can also adjust your stock size, but you can also always reposition this later in the Carvera controller app, which we'll look at in a few moments. So let's prepare our toolpaths for this. And the first thing I'm going to do is machine these holes for some pins we're going to insert. So let me select these 2 holes, and we can create a 2D drilling operation. And for this, we want to drill just a little bit in. We don't have to drill all the way through. These are going to be pins that actually hold some rubber bands for our launchers. So I'm going to set my end depth to be 5 millimeters. I'm going to choose a drill bit for this that I have. So I'm going to select my 3.175 by 12 millimeter drill with my feeds and speeds set to be hardwood. And I have this loaded in tool slot 4. So I'm not going to change any of my feeds or speeds, but I do want to change my tool number to match where I have this in my tool changer if you're using the Carvera. And we do want to use a retract like we did before. So I'm going to keep my fixed Z height retract and calculate this. All right. And then we can close that and move on to our next toolpath, which are going to be a bunch of pockets, So we have the pockets here, these circular pockets for the ball. We have these 2 square pockets for a little rubber band. And then we have these pockets, which we're going to use to make our launcher fit a little bit more loosely in our board so you can swivel it around. So I'm going to hold shift and select all of these pockets, all of them here. So we have 6 pockets. And I'm going to use one toolpath because they're all going to be cut to be the same depth. So 2D pocket, and I'm going to set a depth of anywhere between like 3 and 5 millimeters should work fine. That'll change essentially how loose everything fits together. So I'm going to leave this to be 5 millimeters, should be okay. For this, let's go ahead and select the same 25 millimeter end mill. We use quite a bit for the board file here. So I'm going to choose that end mill. If you want, again, you can choose your feeds and speeds, change your tool number if needed, but I'm going to keep this matching all the defaults and what we did. I'll set this to be an offset strategy, which should work fine for all of these smaller pockets, and I don't need any ramping or anything like that, so we can just go ahead and click calculate, and that will calculate all of these pockets here to be the same depth. If you want to machine these at different depths, you could of course make different toolpaths like we did for the board, but I think for this launcher, this should work perfectly fine. So we can close that. And then the last thing we need to do is machine our contours to actually cut out each of these launcher parts. So let's create a 2D contour toolpath. Okay. The end depth has to plunge all the way through our stock, so I'll use the same 20.5 mil that I did for the board. We need a bit long enough to do that, and as discussed, I'm going to use my 32mm end mill to do this. So I can select that tool. I'm going to change my tool number to match where I have that loaded in tool slot 2. And we're going to run along the outside of all of our lines here. I also need to make sure that the lines are selected. So holding Shift, I'm going to select all 4 outside profiles too. Then we can enable tabs. And just like before, I'll do rectangular tabs, although I'm going to make them a little bit smaller than what I had on the board. These are much smaller parts. So I'm going to keep them to be 10mm wide, but still 5mm thick. And I'm going to place these on my parts on some flat areas. So I'm going to put them on wherever I have some flat edges, avoiding areas that would be really difficult to cut the tabs away. So like, for example, I don't want to put them on any of my curves or like inside of this inner pocket. That would be a little bit more difficult to cut. So just putting them on flat sides of my parts, and then we can calculate. All right. So then we have our tool paths here for everything we need here, for our pockets, our pilot holes there, and of course our contour cuts for the launcher. So I'm going to save this and then export these paths. So then we can start to prepare our CNCs for manufacture.
As this is a larger design, I'm going to be aligning my stock without using the corner clamp. Additionally, you'll need a thicker piece of wasteboard below your stock so that the alignment pins will be well seated for the flip later on. If your wasteboard has a lot of holes already drilled into it like mine, it's a good idea to mark them before fixing your stock so that way you'll know which ones are the new ones when it's time to insert your pins. With the stock aligned to the edge of my board, I've secured it using some wood screws placed on the outside of my machining area. We also need to load our tools into the Carvera's automatic tool changer in the slots that correspond to the numbers we assigned in CAM. Starting with the 25mm end mill in slot 1, then the 32mm end mill in slot 2, and then the chamfering bit in slot 6, we should be ready to start these parts. And as this project will be generating a lot of dust and some really big chips, I've decided not to use the Carvera's built-in vacuum, but instead use a larger external vacuum and monitor my machine during the machining process to safely clear these chips manually. Now moving into the Makera controller app, we can upload our GCode files to our machine for manufacturing. Using the Files menu, I'm selecting all 4 of the GCode files we created earlier and uploading them to my Carvera. With the files uploaded, the Carvera can continue to manufacture them even if I disconnect my computer. Once completed, I can select the file for the bottom of the board to start the manufacturing process. In the Config and Run window, we can set up our project. As we're not using the corner clamp, we need to adjust our work origin to be in the corner of the bed, which will be a position of -15mm in the X and Y offsets. We can then enable scan margin, which will trace the perimeter of our design before machining, allowing us to check to its location and to ensure that no screws or clamps are in the way. And we want to enable auto Z probe, which will probe the height of the stock to measure its thickness automatically. We could enable auto leveling as well if we're using a rough piece of stock or one that's either warped or doesn't have a consistent thickness if needed, as this will automatically compensate for any deviations in your stock thickness automatically. But plywood's pretty consistent, so I'm not going to enable this, and once set, I can press Run to begin to manufacture the bottom of my board. After completing the scan margin and probing operations with the wireless probe, the Carvera will pick up tool 2, used to drill the holes for the alignment pins through a peck drilling operation. Next, the Carvera will automatically select tool 1, the 25mm end mill, and begin to machine the different pockets in our design, starting with the magnet holes, before then machining the slots for the hinges, followed by the large storage pocket in the center of the board. This larger pocket will take a long time to clear with such a small bit and also generate a lot of chips. Keep an eye on your machine to ensure that all hot shavings and dust is being cleared away effectively for a safer and cleaner finish. This would also be a good opportunity to utilize different size spindle collets for the Carvera or Carvera Air, as these will allow you to work with a larger bit shank diameter to clear out material more quickly in circumstances like this. And the bit adapters available in the Makera store allow you to combine larger and smaller shank diameter bits, meaning that a small bit can be used for the smaller pockets in our design, while the larger bit can be used to clear out the bigger areas and cut down overall machine time. Once the center pocket has been cleared, the Carvera will grab the chamfering bit to create a chamfered cut around our design. With the bottom finished, we can vacuum the part before unscrewing it from the bed of our CNC. Clear any dust off the bed of your machine, then insert your alignment pins into the hole drilled in our first operation. You can then flip your stock horizontally and align it over the pins so that the recently machined bottom is now touching the bed. With the pins still inserted, re-secure your stock with screws before removing the pins. Back in the Makera controller app, we can load and configure the G-code for the top of our design using the same offsets and settings that we did earlier. Once set, press Run. After the probing sequence, the Carvera will begin by machining the pockets using Tool 1, starting with the cup holes, then followed by the launcher holes. Again, ensure you're clearing dust during the manufacturing process as needed. The Carvera will then select the longer end mill from slot 2 to cut out the part through our contour toolpath while keeping the part secured with the tabs. Lastly, the Carvera will grab the chamfering bit to create a chamfered edge on the top of our part as the job finishes. Now, as I've chosen to laser engrave the engraving design rather than machine it through a milling operation, I now need to thoroughly clean the work area of any dust which could ignite during the engraving process. I also need to remove the protective cap over the lens of my laser and ensure that I'm working in a safe and well-ventilated environment for laser engraving. Back in the controller app, we can load our G-code for the engraving steps before configuring it for manufacturing. We want to keep the same work origin offsets and again use scan margin and auto Z probe, which is used for setting the focal length of our laser. But we want to adjust where the auto Z probe measurement is taken from, as we need to ensure that the probing is on the surface of the stock, not inside one of those pockets that we machined earlier. So I've adjusted the auto probe location offsets to be 150 in the X-axis and 40 in the Y-axis from the path origin, just to make sure I don't accidentally probe into one of the pockets that's been machined. Once set, click Run to start engraving. After completing scan margin and probing sequence, the Carvera will begin to engrave the part of the design using the built-in laser module. Again, ensure that you are in a well-ventilated space and always wear eye protection when working around lasers. Once complete, we can unscrew our stock and use a handsaw to carefully cut the tabs holding our design. We can also use some sandpaper to clean up the areas we cut the tabs off of and clean up any splinters or rougher edges too. You can then repeat these steps to make the same part again for the other side of the game board. And once the parts for the game board are finished, we can then manufacture the launchers. Again, start by securing your stock in the bed of your CNC and ensure that your tools are loaded in the correct slots based on your CAM settings. We'll be using the same tools for the launchers, plus a 3.175mm drill bit loaded in slot 4. In the Makera controller app, we can select the G-code file for the launchers uploaded earlier. In the Config and Run window, we'll be using the same settings that we used earlier on, but you can adjust your work origin offsets as needed before running this job. After completing scan margin and probing operations, the Carvera will select the drill bit first to drill our 2 dowel holes. Next, the Carvera will use Tool 1 to machine the different pockets in our design, followed by Tool 2 to cut each part out through a contour operation. Once the job is complete, vacuum away any dust and remove the stock from the bed of your CNC. You can then carefully use a handsaw and sandpaper to cut the tabs and clean up the edges of all the launcher parts. Now, to finish the launchers, we need to carefully drill some additional holes on the side for assembly, either using a handheld drill or a drill press. I'll be using 1/4-inch dowels for my assembly, so I first drilled out the dowel holes made with the Carvera to fit the larger dowels that I have. Next, I drilled holes through the sides of the uprights for the launchers, and then marked holes on the arms of the launchers by placing a pencil through these upright holes. After drilling out the arms, I'm ready for assembly. The first step for assembly is to glue 3 small magnets into the bottom of each board side. Once the glue dries, align and clamp the 2 halves of the board together and install small 1-inch jewelry box hinges by first drilling pilot holes before inserting the screws for the hinges. To assemble the launchers, you'll need 2 smaller dowels, approximately 20mm in length, and 2 longer ones that are approximately 60mm in length, as well as 2 rubber bands. The smaller dowels can get pressed and glued into the holes on the front of the uprights, and these are going to be used for holding onto a rubber band. The longer dowels can be inserted through the uprights and arms as a pivot point, but don't glue these as they'll need to be removable for storage. With the launchers assembled, thread your rubber bands around the notch created in the arms and around the lower pin and fire away. You can easily swivel and aim the arm within the board pockets and then disassemble them so they store neatly in the pocket on the bottom of the boards. And that's all there is to it. This was a longer and more complex project to prepare, but one that shows the versatility of both Makera CAM and the Carvera Desktop CNC. Thanks for watching. Of course, please don't forget to subscribe, and happy gaming.